Nice to see you. Welcome to today's lunch hour lecture. My name is Adam Dennett. I'm the head of department in the Bartlett Centre for Advanced Spatial Analysis. And today I'm employed as Andy's hype man, basically. So I'm here to get you all kind of pumped for this killer lecture that Andy's going to give you. Andy's one of our newest members of staff in CASA. Very recently joined us as a teaching fellow in the summer, been doing some excellent work with me around kind of spatial modelling, GIS, that kind of thing. Andy joined us from the University of Southampton, where he completed his PhD, and I think this is what he's going to be talking about today, some of the work he carried out in his PhD. He spent a fair bit of time over in Australia, and I guess we're going to get some Australia stuff in there as well. Yeah, fantastic. Before that, Andy was an undergrad at University of Sheffield doing geography, so impeccable pedigree for this kind of work. So I won't dwell anymore. I'll let Andy talk to you, and over to you.
Okay. Oh. Okay. Thanks. So yes, I'm Andy, and today I'm going to talk about Earth observation for planning sustainable cities. Currently, at the moment, about 50% of people live in cities. By 2030, that's predicted to rise to roughly about 60%, which is an estimated extra billion people. During that time as well, urban land cover is expected to triple based on 2014 base level. It's one of the world's most transformative trends that's basically happening right now. So before we sort of get into it, let's start with a scenario. You could be a state, local government planner, and you've been tasked with creating a more sustainable and data-driven development. Specifically, you've been asked to focus on mitigating excess temperature. And this last bit we'll come on to a bit later, but essentially we're going to focus on the urban heat island effect. And the urban heat island effect describes the temperature difference between urban and rural areas. So often urban areas are between 1 and 6 degrees warmer than rural areas. But yeah, so we'll come on to that and why it's important. So as this sort of task, you perhaps want to understand what's going on with international policy. What do the big people say about this? So we look to the Sustainable Development Goals. And now the Sustainable Development Goals are essentially a blueprint for better and more sustainable future. So if we look at the Sustainable Development Goals and we have a look at what does it say about urban area, okay? So if we look over here, these are the 3 targets of a particular goal that talk about urban area. And you'll notice that 2 of them, so this 11.3, it says urban area considered annual amount from local planning authorities. And then down here, 11.7, says national governments required to determine land use maps. Now, the problem with this is that different countries, different planning authorities do things completely differently. So you've basically got this international metric that isn't really comparable across nations or cities because everyone is different. So okay, it's been adopted by 193 countries, so okay, it's sort of a starting point. Now, where should we go from here? We could turn our attention to C40 Cities. C40 Cities are a collection of 94 cities. It was originally 40, hence the name, and it's the mayors of those cities. So C40 Cities, all these mayors have signed up to their initiative. It's a charity, and they basically want to increase sustainability in cities. Okay, so we can have a look at various things here. They don't really provide many methodological guidance. They just sort of promote sustainability. So they might help you apply for some funding. For example, they've had successes in Hong Kong where they put sort of reflective roads down to bounce back all the thermal energy that comes up. And in Washington, D.C., they worked with local governments to only procure buildings with rooftop gardens as a sort of deterrent of heat. Okay, so we could also look at the New Urban Agenda. So this was adopted by the United Nations a few years ago, and it focuses more on local policy. So specifically, it wants to improve construction, management, operation, and livability of cities. And it's a massive document. But if we filter down where it talks about temperature, we can turn to point 54. And here it says, reducing the financial, environmental, and public health costs, inefficient mobility, congestion, air pollution, urban heat island effects, and noise. So equally, this is signed up to by all members of the United Nations. And again, they don't really have any method for it. It's just, they sort of just put the legislation out there and they let cities get on with it. They do have what's called the City Prosperity Index. But that's more city profiling. It's not, they don't really tell cities what's wrong with them. It's almost like a radar chart. And like, I don't know if you ever played those football games where your football player had a, attack and defense and something like that. That's basically what that is. And it's chargeable per city. The methods, I believe, are a black box, and I couldn't find them. So it's just not very helpful, really. So the first thing you'd probably want to do as this planner is work out what has changed over this time. How do we actually monitor urban growth to see what's changed in the past so we can plan for the future? And this talk is now going to go into a bit of remote sensing or Earth observation. So I'm going to do a quick crash course in that, Remote Sensing 101. So with remote sensing, you've basically got the sun's energy coming in, it reflects off the Earth, and the satellite monitors the reflection. There are a few different, what we call resolutions. So you can have spatial, which is basically if you ever used to have one of those old cameras, megapixels, 10 megapixels, 20 megapixels, the higher number of the megapixels, the better the image. It's the same thing, essentially. So here we have an image over Perth, and it was collected by a plane, and it has 20 centimetre resolution. So you can see it's quite crisp. When we've got 1 kilometre, we go down to 0.1 kilometre here, you can make out all the individual houses. Same thing from the satellite, and it's just a bit of a blurry mess. But the difference between those two is that this satellite collects every 16 days. This aerial imagery collects on demand. You have to charter the plane, you've got to put it up there. You're talking hundreds of thousands of dollars per flight. The second one is spectral, essentially the number of bands. As humans, we see in the visible. So all our images are made up of red, green, and blue. But satellites and sensors can see in much more of the electromagnetic spectrum. So near infrared, mid infrared. And essentially what this gives us is a signature, a spectral signature. Now the way I describe this to most people actually is, it's like every person in this room will have their own signature. So every bit of land across the world will have its own signature, which you can see in the electromagnetic spectrum. So if you know the characteristics of something, you can then pull that out of the image. And temporal is the time between collection. So how often do these sensors pass a particular point? The City of Perth 101. So I will sort of touch upon other cities here, but mainly this is based in Perth. Perth is the state capital of Western Australia. Originally it was called the Cinderella State because of the perceived neglect from the rest of Australia and the other states. However, that all changed in about 1994 when there was sustained discovery of natural resources. So originally it was valued at around $4.7 billion in 1994, and in 2013 it hit $121 billion, the valuation of the industry. So basically, the other name for Perth is Boomtown, because within a very short period of time, it had a lot of wealth coming from the mining industry. And what happened? Well, it grew massively, huge urban and outward development. And this is sort of the picture that's characteristic of the city. Outward, low density, everyone has their own house. The only real high-rise buildings are in the city, most of which aren't residential. And this has caused a lot of problems in Perth. And the Western Australian Planning Commission actually have addressed this in some of their recent planning literature, and it says we need to address the outward expansion of Perth. It's inefficient in terms of resourcing, it's causing ecological degradation. Basically, they're struggling to service all the new residents who are on the outskirts of the city. So you might be thinking, okay, now we're a planner, we've got a massively expanding city. What do we currently do? What is available right now? What is our method for looking at this expansion? Well, before 2009, the Planning Commission used to look at these things called land parcels up here. So basically, a plot of land that someone might own. And what they do is they'd assign a value to each of these land parcels in dollars. They wouldn't tell me the value, so I don't know what it is. I assume it would change based on where they are as well. And if a particular parcel hit a value threshold, they would define that as urban. Okay? Then after 2009, they changed everything. They still sort of considered that a bit, but now they introduced two types of urban. Urban based on the threshold, and also urban deferred, which is land they wanted urban to develop into. So it's something they'd potentially zoned and thought, yes, that's where the future of the city will be. We'll now include that. And they also decided to include spatial modelling. Again, they didn't tell me what that was, even though I asked several times. And they've set these targets. So they want 40% of future development as infill and a 50% increase in density. But they've got no way to monitor them. They basically use census data, which in Australia is collected every 5 years. So they use census data to model density, and the infill is land use type that comes again from the land parcels. So you sort of have this question that, is this actually representative urban? Do they have a good history of tracking changes through time? Is this the best we can do? And what are the implications for making wrong estimates, which they could potentially be doing? So how do I propose we do it? Well, we use satellite data. In particular, this is the Landsat satellite data, which has been going since about 1990, I think. And you can bring all the imagery together, and you can model, essentially, your land cover to see how it changes over time. So basically, our estimates show that between 1990 and 2015, the urban area in Perth increased 45%, about 320 kilometres squared. So huge. In particular, you see down the south and the north is where they're really sort of booming areas. Sort of another way to look at this as well and highlight how dispersed this is, the maximum population density in Perth per kilometre squared is about 3,500 people, the maximum number of people per kilometre squared. Sydney and Melbourne have 10,000 people per maximum, 10,000 and 14,000. So just, if that's the maximum population density you've got per kilometre squared, it's just, well, amazing. Okay, so we've sort of looked at how we find out urban area. What about now potentially thinking about how we select land? Where's the best place to guide this development? What area should we pick for the city to develop into? So now I'm going to talk about the urban heat island effect. The urban heat island effect describes the temperature difference between urban areas and rural areas. It's a function of two main things. One is an increase in impervious surface area, so dark surfaces, pavements, roof materials, and two is a reduction of vegetation. So vegetation in the day will provide shade and it cools the urban environment. Evapotranspiration also takes energy out of the urban area and disperses it. So when you come in and sort of just rip an area up and concrete then the temperature will probably increase. Yes, the main point of this slide. A lot of people say, well, it doesn't matter. A couple of degrees here, who cares? Not an issue. So I've sort of made this slide and some of my recent publications about the 1 degree effect. What does 1 degree increase in temperature change? Well, in Hong Kong, above 29 degrees C, we saw a 4.1% increase in mortality. 1 degree C rise in the US has been associated with 21 watts increase in energy per person. In Bangkok, a 1 degree C increase saw a 7.5% increase in electricity consumption. And basically, especially with the electricity, you've also again got particulate matter, nitrous oxide, all this other stuff that potentially power plants are producing, which again harms human health. And yeah, the 1 degree C, this is in Phoenix, was found to increase water usage by around 290 gallons per household per month. So just 1 degree C can cost cities a lot of money. And then we sort of draw our attention to Melbourne, which I believe is the first city to conduct an economic assessment. So they basically, the methods weren't great, and I'll show you how we can improve them, but essentially what they decided to do was this valuation, and they worked out every year excess temperature cost them $300 million a year, of which healthcare is 282, and the rest is composed of antisocial behaviour, animal care, and tree maintenance. So it's a huge economic expense every year that could potentially be resolved with quite a straightforward method. Okay, so what does Metropolitan Policy say? So here we've got Perth and Peel at 3.5 million, which is the guiding documentation for the development of Perth. The London Plan, which is, well, the same sort of thing for London, and Johannesburg Spatial Development Framework. Now, I've selected these because they were the most open and transparent. Others are available, but that's why I've picked these ones. Normally, in these kinds of documents, they do recognise the impact of temperature and urban sprawl and all the issues associated with that. The best one is actually the London one, which it's mentioned 13 times, and they seem as if they will reduce and avoid the urban heat island effect. The Perth one, it has 16 aspirations for sustainability, of which excess temperature is one. And in it, it says their mandate, the planning commission, so these are all normally planning commissions or metropolitan authorities, they say their role is to support local governments in mitigating the urban heat island effect. Right? They don't want anything to do with it, basically, is how I interpret it. They are devolving that responsibility to local governments with minimal guidance and saying, we will support you. So basically, none of these have any kind of associated method. They don't really show you how you can select land for future development. Even the Perth one, when I asked, I found the actual map with the file path name, and said, can I have a look at this, please? And they said no. It's often left to local governments, yet all those documents say future land rezoning must meet the strategic urban planning objectives rather than in response to individual requests. So the planning commissions are setting out their future land objectives. They're giving minimal guidance and telling to all these local authorities, good luck, this is what we want you to do. So again, I'm going to sort of take you through what we proposed. Your traditional urban heat island studies will take a point, say, in the city over here, and a point in a rural area here, and just say, the difference in temperature is 4 degrees. But that's not much use if you actually want to know what land cover conversion could we use that will have least impact on temperature? Where should I be developing? You know, should I be changing forest to urban area? Should I be changing grass, bare earth? What decision should I be making? So here we sort of have, this is urban area, percentage of urban area per 500 meters squared. This is the same for forest or other. And essentially what you see is, as soon as you get into the forest area, temperature, which is this black line, just plummets, and around the urban area, it's much higher. Except the dips here are the river, the Swan River. So what we did is essentially look at the change in land cover between two periods, worked out where the biggest changes were, and what they changed from and to. So here we have sort of the change in land cover, so grassland to bare earth, for example. So in this criteria, it was that had to be the dominant change in the area, and also it then had to represent the whole of that area. So basically big scale changes. And then as a result of this, we produced this sort of quite basic image really, but the reviewers loved it from this. This is a published paper, and they loved it, and it was on the front cover of the journal, because they said it concisely shows what you're trying to say. There's no sort of ambiguity about it. If a policymaker looks at that, they immediately know not to use forest and put a big city in a forested area, because you could almost hit 0.9 degrees C increase in temperature. So the last thing is sort of localized design. And what I mean by this is that I'm trying to go through the whole process here. So we've looked at how urban area has changed. We've tried to show you the best places to develop those new places on the large scale. And then you found those places, you zoom in. Now, how best do we develop those local places to, again, reduce temperature? So what's sort of been done? So these our friends here, the 3 planning documents, again, they just say what I've said before. They just push the responsibility to local level. So the local level come up and say, okay, we're going to try and solve this issue. And normally they have 2 themes. One is voluntary, and the second one is policy. Voluntary is where they just try and encourage people to change their habits or show example projects. So Chicago the city of Chicago have built a green roof on top of their city hall. Baltimore offered tree vouchers at like a B&Q to try and encourage residents to buy and plant more trees. In terms of policy, it has been implemented in certain areas that there's a minimum mandate for vegetation, but only for development over a certain size. So we sort of have Seattle's Green Factor is one, and Baton Rouge's Landscape Ordinance. However, with those policies, there's never any spatial requirement. So you could build a massive development, and then you could meet your vegetation requirement by just putting it all in one corner, out of the way. And that's probably not the best place to have that vegetation if you're considering cooling and well-being as well. Fremantle, which is the second biggest city in Perth, have tried to address this with their urban forest project. So they're aiming to increase canopy coverage by 20% by 2020. So backtrack a bit. This is the Seattle's green policy, and basically it's an Excel spreadsheet. And if you have like a green roof over a certain size, you put it in there and you get a score. And once you hit the certain mandated score, then your development can be approved. In contrast, Fremantle's urban forest actually try and say, where are the hottest places, where should we be planting trees? So this is the city of Fremantle, this is from their policy. I used to live about here, and this is the sort of Fremantle train station area here, and Perth is about half an hour on the train up that way. Essentially what they did is take some satellite imagery, calculate temperature from it, and then average it to city blocks. Now there's a few problems with this. The first one is they only considered January of one year, and one day actually. So already, you've completely ignored the rest of the year. Vegetation in Australia might not be in full bloom. If it's a particularly hot summer, there might be some sort of senescence. And by averaging it to blocks, so you can see this massive sort of park block here, what will happen is that if you've got a smaller block and potentially you've got a very bad or inefficient development here that's causing all the heat, you might only be able to plant trees or do some remedial action over here, which could potentially have no impact on why it's actually hot there. And they have actually used this map to plant trees and increase greening. And this cost them $2.57 million for the whole plan and then several years of planting trees. So what do I propose is the difference? Temperature modelling. So I'm going to show you a few things now, but basically you can take an urban area, model it in 3D, model the temperature using land cover, weather data, and elevation data. And you can actually see on a 1 by 1 metre area basis where the hottest places are, and you can put mitigative action into it. So it's going to flip to temperature. So you can see the trees here and all the shading they're providing and the temperature difference. So let's take a few examples. Right, this is a really interesting one. There's two places here. The high density is a place called Subiaco, and the low density is a place called Currumbine. Now in 2011, both of these places had the same population density. The one on the left, Currumbine, low density, is subject to the Perth Metropolitan Region Scheme. Right, it's the master plan for the Perth area. It's the sort of the guiding principles of planning there. They've been unaltered since 1955. And in them, it says, any subdivisible area must have 10% for open space. It doesn't define what open space is. Don't assume it's a park. It could just be a concrete block. Okay, so that's Currumbine. Subiaco. Subiaco had the Subiaco redevelopment scheme. And that was allowed to supersede the Metropolitan scheme. It was a special sort of sustainable thing. And they tried to increase sustainability, environmental consequences, and livability. And also they wanted to alter land from derelict to sort of commercial and accommodation. So they built it, and now today the Subiaco area has a population double that of Currumbine. They started the same in 2011. It's now double that, more than double in fact. And the temperature of this area, depending on what sort of land cover you're looking at, is between 0.6 and 1 degree C cooler than Currumbine. All that from one simple policy changed the temperature. And if we go back to what I said earlier, the effect of 1 degree C, well, if you do that on a wide scale, you can solve a lot of problems. Okay, so now let's take another applied example. For this case, we're going to look at the Woolstores shopping centre in Fremantle. I used to walk past this place nearly every day on my way to university. So this is what it currently looks like, and I used to walk down this road. This is what they proposed. That's the same road I'd walk down. And this is the new proposal. This is the same road here. So in 2018, last year, this was denied. So I'll give some context actually. This area it's been quite controversial, this development. It's a very nice and up and coming area. It's prime real estate, directly opposite the train station, minutes from a beach. It's sort of the only area, the town, this is the main sort of city, and this is where it is. It sort of hasn't developed this way. And the thinking is, essentially, if you get this right, it could increase development and make that end of the city much nicer. So this is rejected because it doesn't have exceptional design quality. Basically, it exceeds the height limit for the local planning regulations, and it's not exceptional, so they've denied it. The designer estimated it's cost them $2 million over 3 years just to get to that stage. So what do we do about this? Well, we take local planning plans, right? So I asked for a digital version of these and they said no. So I just took the plans on the website and they had plan for every level of the development, and I just digitized them and put them into the computer. And basically I just copied how it is. Made a computer version of this and then modeled temperature. So I looked at the original development, what's currently there. So if we go, so this one, right? And then I looked at this proposed development. I didn't get onto this one. This is new. This proposed development. So what's the temperature of the original development? Use the free open source model the temperature of it. How does that compare to the proposed development? Okay. And then what if I strip all the vegetation out of it, remove all the trees, and then relocate those trees in the hottest areas, right? Keeping everything else the same. So keeping tree height the same, tree canopy coverage the same, distance between trees is the same. Basically, I've tried to maintain everything except for where the trees are. And depending on where you look, it's basically an average of 0.7 degrees cooler, just from doing that. And then if you add that to what I said earlier about finding the right land, you can exceed 1 degree C quite easily of cooler developments. But what about other factors? Yeah, there's lots of other factors. Obviously, I've only really considered temperature, and there was some error. It could have been some errors in how I took the plans and put them into the computer, digitized them. Another potential thing that could be an extension is looking at actually how people move through the city, Strava, or sort of dynamically modeling population. Finally, economic pressures, cheap and quick housing. So again, in West London, I've never seen this anywhere else. You can actually go to these places called display home villages. So it's just normally on the outskirts, and these are our land parcels again. And developers each get a plot, and they can build a display home. And you go along to that display home and you say, yes, please, I'll have the Discovery on my plot of land. And they'll come and they'll build that Discovery house on your plot of land. And you can specify anything you want. If you want the taps a different color, if you want the plugs a different size, whatever you want, you can specify it. And this is essentially why, or part of the reason, the urban sprawl is so bad in Perth. Because this is basically what people are used to. They want to go and have this choice and build them on the outskirts of town. Oh yeah, so call to action. You can actually, this is currently live for receiving public feedback. So you can go onto this website and tell them they should be modeling temperature and not just putting trees in the most sort of aesthetically pleasing places, because it's a waste of time. Yeah, so I guess sort of take-home messages. Broadly, planning authorities can do much better than they are now. The expertise are there. In the case of Fremantle, they're happy to spend $2.5 million on their urban forest plan. But my solution, they could essentially just employ one person, half a day a week, to take the digital plans they receive, put them into the free software. It's not even particularly difficult. Model temperature and say, you need to move your trees here, right? In the long term, that's much more sustainable than just throwing $2.5 million at a problem, in my opinion. Yeah, sort of shown how to determine optimum land cover development in temperature, relation to temperature. And finally, the ideal goal would be to actually have some international methodological guidance. Like, this is how we recommend you do it. And sure, you can have local variations, but just something that planners can go off would make a big difference. So yeah, if we go back to our original scenario, if you're a government planner and you're tasked with making sustainable developments, hopefully now you can see what the problems are and make better decisions. And that's the end of the talk. Thank you.
Right, thanks, Andy. That's fantastic. So we've got a bit of time for a few questions. If you have a question, if you put your hand up and someone around here has got a microphone and they'll be able to take it to you. So any questions for Andy? One over there. I'll take mine. It's close.
Great talk, thank you very much. Do you think economy is always going to be the biggest struggle for the environment in order to sort of decrease levels of heat?
Well, it depends, really. In the example I gave, Perth is so reliant on the mining industry that, yes, because now it has dipped quite a lot at the moment. And the way I see it is that basically the money is drying up for local councils on the outskirts. In other cities, no. And I just think they should consider it more carefully. It really depends what the nature of the city is. But as a broad statement, everyone needs to consider excess temperature more carefully.
Is it on? Yes, it is. I went to Perth in 1976. I was 6, but that's not what I came to talk about. Do you think that the recent news about those extreme fires in New South Wales, what do you think the reaction of Perth developers might be to that?
So occasionally in Perth you do get wildfires as well. And it depends which way they develop, right? Normally it's up and down the coast, so it's not so much an issue. There have been issues of development going inland further to sort of forested areas, and people have been evacuated and villages have been destroyed. It's a problem that doesn't have an easy answer. They try and do prescribed burnings, and a lot of it, unfortunately, is arson as well. So, yeah, especially the times I've been in Perth, it's normally always arson. So, yeah, I personally don't think they should develop into the forested areas because I think it's too risky. But, yeah.
Thank you for the chat. Coming back to the previous point about economics and this policy, agreed that 50% of the world's population is around big cities, and that's only going to go one way. 80% of those cities currently account for 80% of global GDP. Mm-hmm. So we have to somehow link this policy and this thinking to hitting them in their pockets. How do we do that?
Yeah, that's quite an interesting point actually as well, because some local councils in the UK have started to value trees and green infrastructure, which I think this is what I think they should do, right? They should value, if you're, I don't know, say if you're a development like the ones I've shown, if you can actually place a value on those trees and maybe they get a tax break or something, or if they do something well, they should be rewarded. Personally, I think that's the only way they're going to take notice if developers can see a financial benefit, which is unfortunate. But then equally, I think Sheffield, the city of Sheffield here, placed a value per tree and said, if we're going to remove this tree, because there's been a thing about this in Sheffield as well, where they've ripped up trees from the streets. And I believe they've tried to place values on the trees and then almost pay that as compensation. So that's how I would personally recommend doing it, but it's probably not as simple as that.
I just wondered, you concentrated on trees, but have you modelled sort of green roofs and things like that?
Yes, but we haven't shown it because we just wanted to make the point that in that case, all you'd have to do is move trees. It's very minimal work, essentially. It depends on the green roof, how much vegetation you can put up there and how high it will grow. Yeah, there's a lot of factors, but yes, green roofs do reduce temperature and are another alternative. Yeah.
There's one over here.
It's a quick question.
Okay.
Hi. Where would you plant trees in UCL?
That's a good question, actually. I've not thought about it. Normally on the outskirts of main roads. So, for example, the problem is as well, so in that modelling we did, we actually modelled a much bigger area because you have the influence of surrounding buildings as well, causing shadowing across areas. And generally, quite a broad statement here, but generally, if you've got a very tight sort of hallway of buildings, it's quite cool in there because you've nearly always got some shade. But roads are normally a lot wider, and therefore that's where trees should be planted. Yeah.
Yep, no question there.
So
I was on my head.
yeah, okay. Thank you. On? Yeah. So do you get data on excursion of change of temperature over a day or over a longer period of time? What kind of period can you actually sample with?
Yeah. So the satellites can give you, this satellite we use can give you data 4 points every day. The second part, so that was the sort of big scale analysis I showed. The second part, we just used the weather station data because it was only it was basically in Fremantle. And then we had that, we modelled, those models, sort of second models were run every 3 hours for 3 years. So when you play the whole animation, you can actually see like the sun coming up and then the sort of temperature changing based on the aspect and yeah.
And would you model or would you have guidelines for the type of plants you could plant?
You can actually include it, but I didn't because it was already getting a bit much.
Is anyone looking at the impact, for example, on biodiversity of the changes in temperatures? And
I don't know. Probably. I don't. Yeah, not sure. It's not really my area, but yeah, it would be interesting to see.
I thought I had another one.
Yeah.
Oh yeah, and alongside planting more plants or trees, what other measures? So you look that if you have a big water, basin, you would get a drop in temperature. So maybe having more surface water could be a
So
solution.
that's another thing as well. Some developments also include sort of water is the big one as well, right? But hardly any development will include a large water area. I'm not sure what that model would show, but I'd sort of hypothesize that if you had some kind of fountain or I don't know, integrated water feature, that yes, you'd see a reduction in temperature. But then equally, you'd have to probably put energy into that, and yeah, it really depends what kind of type it is, because if you're having to put energy into it to create that fountain or whatever, the heat expelled from that could outweigh the cost. Yeah.
Thank you very much. That was very interesting. Sorry. I was wondering if you were also looking at other data sources, so for example, emissions.
I haven't, no. Yeah, again, it could be another extension to this as well. Yeah, thanks.
Yeah. Yeah, so following from this previous and a couple of comments here and what you said about Sheffield, there are several local authorities like Manchester, Birmingham, even London has done this valuation of its green infrastructure. And like you said yourself, it's less simple than that if you look at more values or more benefits than the, for instance, the heat effect. So even though it might be tempting to say that just put your trees into a place where they reduce the heat effect, it might not be the place where the trade of all those benefits, which include also the enjoyment of people of those trees or squirrels. So so if you are suggesting this value of nature as the solution, then it gets kind of, there are winners and losers and trade-offs in all of those values.
So basically, there's lots of things that could influence where you put them. Because blue and green spaces have also been seen to have positive influences on mental health, for example, mental health outcomes. And then if you try to put a value on that as well, then it could add a whole load of factors that could influence where you place vegetation effectively. It's a starting point, and this is quite an easy problem to see how we could solve the problem, but equally I'm aware there's loads of other factors, like you've said, that would influence on where to put these things. yeah, it really depends from, I guess, our point of view, how much spatial data there is available as well. Normally, mental health outcomes are associated to a particular point, which is very difficult to then interpret and sort of have across a larger area. So, yeah, this was the most straightforward analysis to do, but equally, yeah, I'm aware that other things influence.
Okay. Yep.
Hi. Considering that you're using remote sensing data, would it be easy to scale this to?
Yeah. Yes. So the only real requirements for the last bit of analysis, the more detailed stuff, as long as you had like an elevation model of heights, but even if you just had planning, if you just had those blueprints I showed, you can basically do this. The last step, that is, yeah. And the other stuff you could do anywhere, yeah.
Yes, hello. And I apologize if I missed this in your talk. The plotted area that I was looking at was one property, and how rearranging trees on that property would help the temperature on that property.
Yep.
Is your model able to then explain how reductions in temperature on that property would affect the temperatures of the neighboring properties?
Yes. Yeah. So you can model basically as much as you want. So I just showed one property, but we actually modeled the entire like census area that we had for that area. And when you change something, it will obviously have wider implications. So if you increase the building height, you'd shadow differently and so on. So yeah, it's as much spatial area as you want to give it, it will cope with. But it takes a lot of time as well. So especially if you this is at 1 meter by 1 meter resolution. And yeah, the more area you have for it, the longer it takes, basically.
The spillover effect is significant.
It depends what, really. It depends what. So the trees I showed you, sort of, as I mentioned earlier, if you put them along the road, then yes, that is quite significant to the neighbouring properties. But if you put them in the development, less so. Yeah.
Okay, I'm just conscious that it's 5 to 2, and I know Andy's actually giving another lecture at 2 o'clock today. So just to give him enough space to go to the loo and have a quick drink, if we could just thank Andy very much for his fantastic lecture.